Hi everyone, myself Megha. I am pursuing my Masters in Robotics with Middlesex University, Dubai. My student ID is M00911962. I'm super excited to welcoming you all to the demonstration of my project, which is Saudi Sign Language Translator, which is the end result of a module PDE 4439, which is the final project. So, this project is designed to address the communication barriers faced by deaf community in Saudi Arabia. Despite significant advancements in sign language translation technologies, for languages like American Sign Language, Saudi Sign Language remains underrepresented. This gap limits interactions between deaf individuals and the rest of the population, which is especially important in critical sectors like public services, healthcare, and education. Let me take to the objective of the project quickly. Yeah, basically, there is like a four section of the key contributions, and it is like creation of comprehensive data set for this SSL gestures, development of gesture recognition system that is using multi-layer perspectron model, and third, the system translate recognized gestures into speech using Google's text to speech API, allowing for seamless communication. Furthermore, the entire system is integrated as ROS nodes, which means it can be deployed on robotics platforms, making it scalable for different use cases. Let me dive into this first step, that is dataset creation. Yeah, before that, these are the Saudi Arabian Sign Language gestures. So here, this project completely provide the baseline for the continuous SSL translator. For example, in here we are just using the letters, but through the same pipeline we can develop a continuous SSL translator. Like will be in future, we can translate the complete sentences to text and also audio. These are the numbers. And yeah, here it comes. So this is MediaPipe's hand landmark. MediaPipe library is in Google's open source library, which makes all these, I mean, for us to assess all these landmarks in the hand. So we know that there is 21 landmark points in the hand. And the dataset for SSL translator is not just the landmarks. Instead, lots of calculation has been done behind the scenes. Like so, for each landmark, the distance between the wrist point is calculated. For example, distance from 0 to 5, 0 to 9, 0 to 13 are all calculated for each signs, and the complete values are normalized so that the values will be from 0 to 1. It will be easy for model to learn the difference between the gestures. Let's just take you to the data set, which is done with all this pre-processing. For example, you can see here. So this is sign names, and these are landmark points, up to 21 points. You can see it here. And the dataset size is almost around 28,502 rows 22. And for the same, for numbers, it is two hands. So you can see, instead of having one hand a landmark point, you can see both the hands. See, from 21, it is again starting right hand and left hand landmark points, with the same calculation are being saved for number data also. And these These are the data sets which is used for training. Basically, these are the tools for collecting data. This is for sign, that is only using one hand, and this is for both hands. Basically, it is having difference. Here we have to encounter both left and right hand. So you can see it here, left hand and right hand. And for the single hand, it will be only uh, dealing with one hand data points. You can see it here. And so these are the data point collector. After collecting the data points, we have to train the model in MLP. So that is multi-layer spectron models. This is the end result of the model, which is trained on sign data alone. You can see with hyperparameter tuning, it has achieved a good accuracy 99, which is again in the test result it is 100. So as it is bypassing this hyperparameter tuning, it's not overfitting as much. And this is the model which is developed for numbers alone. You can see almost similar accuracies are achieved in here. And from that, so for testing these models separately, have other tool which you can just check the performance of these models separately. And as a complete pipeline, I have developed this program. So I'll just go through quickly, like how can we integrate. So by importing necessary libraries and calling these two models, that is sign model and number model. Here you can see this is Google's API, which is text to speech. And in here we can just select the language in which we want the tone to be. I have selected Arabic here. And I'm going to run the final pipeline. I have just kept the slide open so that we can validate the results whether it's right or wrong. So first Aleph,
ألف
then Ba,
باء
Ta,
ثاء
this Ta,
ذا
Jim.
جيم
You can see, cross check it with these images.
ها كا
Say,
ذي
say.
سين
I'm just moving the cursor. Just
شين
to check.
ساد داد تا ث ف كاف كف لم ميم نون هي
So almost we have checked all the signs. Yeah, this dal we haven't.
دال
The thing is, the position of each finger should be similar
ثل
to the sign which is mentioned on the figure. Yeah,
عين بين وو
so I have added some delays so that I mean, if there is some misprediction, it will be giving two sounds very simultaneously. That's why.
لا
Okay. So let us check some numbers. So,
با 1 2 3 4 5 6 7 8 9 10
so what we have just heard is all English strings. So, for example, we can just make the numbers to Arabic. This, yeah, you can see it here. I'm just converting this dictionary to Arabic. I'm using this dictionary instead of the above one. Let us see what difference it is making. Sorry, one second, got an error. Yeah, sorry, I just uncommented this too.
واحد. اثنان. ثلاثة.
So these are the Arabic numbers.
أربعة. أربعة. خمسة. ستة. سبعة. ثمانية. تسعة. عشرة.
So likewise, we can map to the Arabic words as well for both signs and numbers. What we have seen till now is completely developed in Python. We need to integrate it with ROS environment. So I'm just going to demonstrate how the India project is divided into two ROS nodes, how it is integrated with ROS and how it's working. For the same, let me open up a terminal from this location. I'm going to show how the ROS nodes are going to work and how they are going to communicate with each other in order to make the system running in ROS environment. To set up two terminal, like I'm going to open one more terminal so that we can run parallelly both nodes. As this is already made in, no need to go with the Catkin make. I'm directly going to source. Sorry. Set up bash. This new terminal score can be run. Again, I'll source. Now I'm going to run the first node package name So this node is responsible for taking camera feed and sending to the other node. I'll just run that also. Mm, See it. This is the second node. Basically, what this node is doing, the first node is responsible for taking the image from the camera, then sending it to the model according to the number of hand it is shown.
شين
Sorry. So yeah, it is like two hands. If two hands are shown, then it will be going to the number model. Just what it's doing, this model will be returning gesture label, which is nothing but the sign name. It will get published to gesture label topic in string format. Will get the string and using Google's API, it will be able to uh, translate it into audio.
ألف
So some signs we can just quickly check.
ثل ب واحد اثنان
We can just open up another terminal and quickly check for rows topic list. You can see gesture label. So to this, the first node is responsible to send the gesture sign name to this topic. So that said, node will be subscribing to this topic to get the string message and it will be converting to audio. Just check our Qt graph as well. So yes, here you can see this is text to speech, that say it node, and this is hand sign, that is the first node. It will be sending the gesture labels. This is two nodes. So this will be responsible for taking the picture from camera and sending to model, and that sign name will be passed to this topic, and this say node will be subscribing to this topic and getting back the audio. That's it. Hence, by offering precise translation, this SSL translator serves as a foundation that can be further developed into a fully functional translation tool. It aims to enhance accessibility and empower the deaf community to engage fully in all the areas of society. Thank you so much.